All right, so today we are going to do our very first day of notes. We've got about 20 minutes left. Hopefully, I want to do this pretty quick. To start today in math, whenever you learn how to do something in math, like for example, when you're in first grade, oh my gosh, it's already a bit of a mess here. When you're in first grade and you learn how to add something, addition, the very next thing you learn how to do after you learn how to do addition is you know how to do subtraction, right? They tell you how to do something, and then they tell you how to undo it, right? And then you learn how to multiply, and then you learn how to divide. Now, this is like fourth grade or whatever. I don't really know, but then you learn how to multiply, and you learn how to divide. And dividing is the just opposite of multiplying. Let me get away from this green color. And then you learn how to do some other stuff that's a little more complicated, right? Maybe in seventh grade, again, I'm just kind of making these numbers up though, you learn how to square something. And then soon after you learn how to square something, the opposite of a square is called a square root, right? And we'll talk a lot about square roots this year, and we'll get better about those. But you can see how these are kind of the opposite things. Now, this is algebra. This is a little bit slow. Let's see if I can do erase. Still figuring out how to. There we go. How to use this. Ooh, bit of a mess. So one of the things you learn how to do is you learn how to distribute things. Okay. So let's do a little review of distributing numbers, right? If we've got 5 parentheses, 3x plus 2, this is just one thing times 2 things, and we just have to multiply the 5 times both of them. And so you get 15x plus 10. Distributing, everybody loves distributing. It's pretty easy. The only way it gets a little more complicated is if we have a negative sign, but it's pretty relatively simple. Okay, so what we're going to do now is we're going to do the opposite of distributing. Okay, so you already know how to do distributing. Hopefully, this already feels pretty good. It is time to undistribute. It is time to go backwards from distribute. So basically, we're going to get a question like this, 15x plus 10, which as you can see, is the same answer. And we're just going to have to undistribute. And what we're basically trying to do is figure out what does this piece and this piece have in common that we can just unmultiply from both of them. Now, pretty easy here. We're going to do, obviously, going backwards. You guys are smart students, but yeah, we're going to undistribute the 5, which basically means we're now going to be thinking about it as like dividing this by 5, dividing this by 5, and we get back here. So that's what we're doing. Let's get into the actual notes now. If you look at these examples here, we've got 2m squared minus 6m, and we're thinking, what can we take away from both pieces? What do both pieces have in common? And because we're doing distributing, which is multiplying, we're always thinking about multiplying, not using addition or subtraction. And so the answer, this is the answer here, but they've said that there is a 2 in common. 2 and 6 can both be divided by 2, and there's an m in common because this one has 2 m's and this one has 1 m. This example is more complicated. We need something to take away from all 3 of these things. And it has to come from all 3. It can't come from just 2 of them. It has to come from all 3. And so what they've decided is that 28 can be divided by 4, 12 can be divided by 4, and 20 can be divided by 4. And so 4 is allowed to be undistributed. Then we've got 5x's, 3x's, and 2x's. And so they're all able to give away a maximum of 2 x's. So the first issue you can have when you kind of do this is you say, well, the first guy's got 5 x's, this guy's got 3, and the last guy's got 2. Well, you know, this one has 5 and this one has 3. They can both give away $3. But because he's only got 2 X's, that's kind of like the limiting factor of how much we're allowed to give away. Now, this is called greatest common factor because we're trying to come up with what is the greatest thing that they have in common, right? The biggest common factor. But it's really just undistributing. So let's go down to number 1. Let's work on number 1. So what does this term and this term have in common? We've got 2 kinds of things to keep in mind if you go back here. We've got numbers, which they might have in common, and we've got letters, which they might have in common, right? Which we call variables in math, but whatever, first day of school. So I like to think about one or the other first, right? Don't try and do them both at the exact same time. You want to handle numbers first or you want to handle letters first? What do you think? Doesn't matter. Numbers first, sure. So we've got a 3 and a 12, and we're trying to think, what can we divide both those numbers by? I'm with you. 3, absolutely. So we can lose a 3 from here. We can lose a 3 from here. And so a 3 can come outside. Now I'm going to leave myself a little bit of room here because we might have some letters that go here. But then what numbers get left behind in here? What number goes first from this piece? We had a 3 from this first one, but we lost the 3. So yeah, just a 1. Or really, we wouldn't have to put a 1 there, but we can. That's fine. And then we have a 12. Is it a 4 or a 9 that goes here? 4. Easy. You guys absolutely killing it so far. Now this looks funky because we've skipped over our A's so far, but let's go back to letters. We've got 2 A's and 1 A. So how much can they both give away? Only 1. So one of the A's gets taken out. And then we just kind of do like a, how many are left, right? We had 2, but we gave away 1. There's only 1 left. We had 1, but we gave away 1. So we have none left. So that is our final answer. And yeah, you could totally write this without the 1 if you wanted to, right? Both of these are the same thing. Just because it's the first day in class is the only reason I'm telling you that, because I'm sure you guys know it already. But yeah, pretty easy. Number 2, do me a favor, do number 2 on your own. Very, very, very similar to number 1. So I'm sure you guys are going to be handling that no problem. Almost remember everybody's names. There's only one name I can't remember. I won't tell you who that is yet. Oh, I'm already looking at second period. All right. Well, I'll just leave it a mystery for now. Where am I going? Here we go. So, do me a favor, Sienna. What was your greatest common factor? What was the amount you were able to take away from both of them? A 5, just a 5? Including the letters. How many, take any letters out? Yeah, I would take out 5x total. Maybe that was confusing because we did them separately last time. So if we lose the 5 and we lose the x, what did you have left over in the middle, Caitlin? Is it 7 or is it 5? Or is it 3? Yeah, because 5 times 3 is 15. 5 times 5 would be 25. 5 times 7 would be 35. No big deal. First day of school. Plus, if you guys haven't put this together, this is the longest you've really ever been since taking math, because you've never waited a full year and a full semester to start after Christmas. So absolutely, totally cool if this is like not going great in your head. Number 4, just ignore number 4 for now. This is what we're going to be working on later. It's the same thing. It just looks really weird, so it's not even worth our time. Number 3, this is the first question. You know, we kind of got a little bit of a hint of this in the examples, but we've got to take stuff away from all three parts and be extra fair coming from all three parts. Now, unfortunately, it's literally the exact same question as the example. Wow, very cool, very interesting. So maybe not the most interesting question of all, but what we're thinking is that 28, 12, and 20, all of these can lose a 4. Again, we kind of already went over this because it happens to be the same exact one as the example. And then we've got, sometimes students struggle with the letters. And in my mind, you want to kind of think of it like you're all trying to make a donation, but you have to make the same exact donation, right? So if I've got $2, Jamarius has $3, Cheyenne has $2, or sorry, you would have $5 because I already said I had $2. But anyways, even though you could give $5, if we said we're all going to give the same amount, because I have 2, we have capped ourselves on that. So yeah, 2 is as much as we can give away. And then we're kind of doing like a dividing game. The way I like to do it is say 4 times what gives me 28, which is basically the same thing as dividing. But 4 times 7 is 28. Cheyenne had $5. She lost 2, so she's got 3 left. This would be 3 with 1 x left, and this would be a positive 5. Again, kind of lame because we already did this question. Number 5. For number 5, we have multiple letters going on here. We have P's and Q's. So when we're doing this, we want to handle it one thing at a time. And so let's start with numbers. If we've got 9 and 3, what's the most we could take out of there number-wise? 3. Absolutely correct. Now, what about letters? Let's do P's first. How many P's can we give away? Just one P. And then how many Q's can we give away? None, right? This guy has a Q to give away, but this guy has no Q's. And so we're unable to give any Q's away. And so that's the end of it right there. So leftover now. A lot of times this leftover part is the hardest part for students, not the taking out stuff. So basically, we need to make sure that if we multiply this, it would turn in to whatever we have up here. So what's getting left over here? 3 times 3 makes 9. If we had 2 P's and we lost 1, we have 1 left. Then we have a minus. We have 3. And we started with a 3, so we have no numbers left here, right? It's kind of like a 1, but we don't have to write the 1 as long as we have something else that's there. And since we lost the P, but we didn't lose the Q, it would be just a Q there. And you could write the 1 if you wanted, but you don't have to write the 1. So there's basically 2 more things I want to talk to you guys about, and then that's it. This is like the whole thing. We've learned it all already, but the first thing, I guess, is that if this is ever hard to you guys, you can always just distribute and just make sure you got the right thing, right? Because if we're trying to undistribute to get our answer, if we redistribute, we should go back to where we started. So if we're ever not sure, you can say 3 times 3 is 9, P times P is P squared, 3 times 1 is 3, P times Q is just PQ. Are these 2 things the same? Yes, right? So you can always double check these really easy by just doing distribution. So hopefully not a whole lot of reason to get this wrong. Now number 6 is the first time we run into what really can be the only hard thing when it comes to these questions, okay? So for number 6, we've got x minus 4x squared. And so a little weird, most of the time, the big complicated portion is the front portion. and it gets less complicated as we go on. This one's kind of backwards, but that's not a big deal. We need to figure out what can we take out of this. And we have 1x, we have 2x's, and so we can take out 1x. So the reason number 6 is complicated is because getting this inside right can be a little tricky. Anybody want to guess what would be inside there? What do you think, man? Negative 4x. So I would agree with you because we had 2x's. We lost 1. That's fine. We had 1x right here, but we lost it, right? Now, if we double check our answer by distributing this, I would get, let me go back and get rid of that red stuff. If we distribute this and double check, I get negative 4x squared. But this is gone. And so actually, negative 4, like you offered, Jamarius, is almost the whole thing. But this is not quite what we need, right? The problem is that this x, it's not x minus an x, which would make 0. It's actually x divided by x. And so what's left over there is a 1. Okay? Again, this is the one thing that can be tricky. There's 5 of you in class, and the odds are if we were going to give a quiz, you know, one person out of the 5 of you would forget this, right? And you'd have an example where something would totally go away, and you have to leave that 1 behind. And all this 1 does is it's like a little placeholder, right? Because now when we distribute this, we're going to get x minus 4x squared. So without that 1, this x would never come back. And so if you're ever going to fully take away an entire thing where this whole thing is going to disappear, you got to leave that 1 behind in order to do that. Let's just skip 7 for now because we're kind of running out of time. Let's finish up with 8. The same kind of thing happens with 8, right? We got to take away as much as we can from this, this, and this. We're going to take away a 5. We've got 2 x's, 1 x, and no x. So we can't take away any x's, right? Even though, you know, person A and person B could both give away x's, person C is kind of screwing that, so can't do that. And so then we got y, y, y. We're allowed to give away a y. And now left over would be, what you got left over, man? Yes? Perfect. Absolutely perfect, Jamarius. Absolutely perfect. Yeah. And so again, this 1 is the one thing that can be a little weird, right? This 5 is gone. This y is gone. So there's nothing left here. But it's really like 5y divided by 5y. And anything divided by itself makes 1. So the way that I always think of this is if you've got 1, 2, 3 parts, you should always have 1, 2, 3 parts. Right? And as long as you keep that in mind, you can't make this mistake. The only time you mess up is like for this question, where if you start with 2 parts and you end up with just 1. So that's kind of the way I think of it, and I keep it in mind, and then it's pretty easy. So this is called greatest common factor. This is part 1 out of 4 or 5, however you want to call it, of factoring. I guess I need to conclude this recording before I talk. The way this class goes is strategically. Years ago, when we used to teach this class, it would go from easy all the way, and it would get harder and harder and harder throughout the year. But what would happen is the students it would start out so easy. Students would be like, this class is pretty easy. And then when it got hard, a bunch of students would always just like start failing really badly because it would just get hard out of nowhere. So what we did is we put the hard stuff at the beginning and the easy stuff in the middle. So the start of this class for the first like 3 weeks, 4 weeks is pretty tough. This first portion, factoring, is in my mind the hardest thing to learn as far as just being hard to learn. So at the start of this class, it's going to be pretty busy. Like I said, you got a lot of stuff for homework tonight, even though it's not a whole lot of homework in time-wise, but you got a lot of different assignments. The only thing about this class is you've never taken a math class virtually and in person. Of course, you haven't done a lot of classes like that, but if you don't ask questions in math class, it can be really hard to learn, especially when you have questions. You know, if you run into a problem where you're going to have questions in this class and then you just never ask any questions, it can be pretty hard. And so what I'm basically trying to say is ask me questions as much as you can this year. The best thing you can do is ask questions, right? I'm telling you, I had students who used to, they'd have one homework assignment and they'd email me 5 times. Hey, Mr. Collier, number 3 is just confusing me. What's going on with that? On this homepage, I've got my email right here. This is not my phone number, but this will send a text through an app to my phone number. And, if you emailed me and, I don't check my email a whole lot after school, but if you want a faster response, you can try to text me at this number too. These are right here for you. Send me emails, right? If I go to my actual email account and I scroll down, so many of these emails are from students, right? From students, from students, from students, from students. And so the more questions you ask, the better. If you're in class, ask me questions. If you're at home, ask me questions. Email me all the time. All right, that's it. First day, not